Okay, let's continue with chapter 7. I'm sorry, chapter 8. It's about confidence interval. Okay, this is important to understand. We are dealing with the interval for the real population parameter based on the statistics, the sample statistics. So we are probably dealing with X bar. Now, we are going to get the interval from where we are going to say with a certain confidence level, okay, where the real population parameter is located. This interval, okay, is based on the confidence level, and we are going to say, for example, that the majority of the time we are dealing with 95% confidence level intervals. So if that is 95, it means, and since everything is 1, that this over here, it is alpha, okay? Alpha, that is the complement of the confidence level, okay? So, since both of them are alpha and this is a symmetrical distribution, this is alpha divided by 2 and this is alpha divided by 2, and alpha is the significant level. Okay? It's important to know this because these values, the confidence level and or the alpha or significant level, is going to give us the real confidence interval. So, for example, if I want to make a 90% confidence level, what has to be alpha? 0.1. What has to be alpha divided by 2? 0.05. What if I'm dealing with 95? 0.95, then alpha is 0.05, and alpha divided by 2 is 0.025. And if I'm getting a 99% confidence level is a 0.99, then my alpha is 0.01, and my alpha divided by 2 is 0.005. Now, why is this important? Because based on this, we are going to get what is called Z of alpha divided by 2. And that is on your book on page 313. For confidence level 90, we are going to get a Z of 1.645. For a 95 is 1.96. And for 99 is 2.576. Now, how do we get these Z's? You go to the standard normal distribution, and you are going to get the values right here. For example, the 95, alpha divided by 2 is 0.025, so this is 0.025, right? So I'm going to get into the table and get 0.025, and the Z value is negative 1.96. So for 95, this value over here is negative 1.96, and since this distribution is symmetrical, this is 0.96 when we are dealing with 96. When we are dealing with a 95% confidence level. And that is the relationship between the level of confidence, okay, how sure I want to be about my inference, and my alphas and alphas divided by 2. And this is my Z. Now, let's do an example of the confidence level for the population mean when you know the standard deviation of the population. move to problem number 8 on chapter 8. Okay. It says, the National Quality Research Center at the University of Michigan provides a quarterly measure of consumer opinions about products and services. A survey of 10 restaurants. Okay, we have a survey of 10 restaurants. So it means that my sample size is equal to 10. In the fast food pizza group showed a sample mean customer satisfaction index of 71. So sample mean, so it's X bar equal to 71. Past data indicates that the population standard deviation is sigma. We're dealing with the population standard deviation sigma, and has been relatively stable as sigma equal to 5. Now, A, what assumption should the researcher be willing to make if a margin of error is desired? Well, since the sample size is not large enough, we have to assume that the population distribution is normal. That is the assumption. B, using 95% confidence, what is the margin of error? Okay, what is the margin of error? Let me explain you first what is the margin of error. In a confidence interval, let's say for mu, when sigma is known, we have the formula x bar plus or minus z of alpha divided by 2 times sigma over square root of n. Well, this is the margin of error. Okay, so, and in my graph, this is the margin of error, because we are dealing in the whole interval, we're dealing with plus and minus the margin of error. Okay, now, what is then, in this problem, the margin of error? Okay, the margin of error with 95% confidence level, right, is z of alpha divided by 2 sigma over square root of n. This is the formula. So just plug the numbers in the formula. What is the z of alpha divided by 2 when we are dealing with 95? Check on the table. Is 1.96 times sigma, that is 5, divided by the square root of sample size, that is equal to 10, and that gives us 10 square root 1 over x times square 1.96 is equal to 3.1. So the margin of error is 3.1. What does that mean for the confidence interval? The confidence interval then is if my x bar, and remember, x bar plus or minus the margin of error. That is my confidence interval. So the confidence interval for this particular case is 71 minus 3.1, 67.9 until 74.1. This is the 95% confidence level for the population mean. So what I'm saying is that I am 95% sure that based on the sample that I have here, I am 95% sure that the real mean of the population, the real mu, is between 67.9 and 74.1. That's what I'm saying. I'm not saying that the 95% of all the values on this distribution is between these two values. What I'm saying is that the real population parameter mu is between 67.9 and 74.1, and I am 95% sure statistically of what I'm saying. Okay?